So let's talk about compound interest. With compound interest, the interest is calculated on not just your principal, but on all previous interest as well. So whatever interest you accrued, you include that when you're calculating the interest. So let's say that you borrowed $1,000, and when you calculate the interest for 1 year, you have to give back, let's say, $1,100. That's pretty high, but let's just use that as an example. Now, the next year when you're calculating interest, you're not calculating it on your $1,000. You're calculating it on the new amount, the $1,100. That's compound interest. It's a little more complicated, but fortunately, we do have a formula to use. Unfortunately, that's the formula. It's a little more complicated than simple interest. That's why we don't call this one simple. A is equal to P times bracket 1 plus R over N, close bracket, raised to the power of N times T. It's an ugly looking formula, but it's actually very, very useful. Let's first of all make sure we understand what all those terms mean. So A is the final amount. So here we're not calculating the interest. We're calculating the interest and the principal all together. It's the final amount that you would get after you include all the interest. P, again, is the principal. R, that's the interest rate. N is something new. It's what we call the compounding period. And it's a question of how often your interest is going to be calculated. So you're still getting, let's say, 1.2% a year, but do you get it at the end of the year, which means your compounding period is one time a year? Or do you get it quarterly, which means you get it every 3 months? So that means that your compounding period is 4 because you get it 4 times a year. Do you get it monthly, which means that the compounding period is 12? Do you get it weekly, which means 52 weeks in a year, so you get 52? Or do you get it daily, so 365? How often does the interest accrue? That's what N represents. T, again, is the term in years, so nothing new there. So now the questions have to be a little different, but let's try and solve one of these questions. So here's a question. Carrie deposits $5,000 into an account, paying 3% annual interest, compounded quarterly. How much money will be in the account after 5 years? So how much money will she have in total? Let's see. There's the formula. A tells us the total after we calculate the interest, so that's what we're looking for. But we need to figure out what those numbers are, and then we have to do this calculation. So it's a little complicated, but let's see if we can figure out, first of all, what the numbers are. P is the principal. That's how much money we started with, and that's $5,000. R, that's the percentage, the interest rate. We're getting 3% interest rate. So I'm going to write that as a decimal. 3% means 3 divided by 100, 3%, 0.03. N is the compounding period. Well, it says here it's compounded quarterly, which means every 3 months. So you get your interest 4 times a year, quarterly. So N is equal to 4. Finally, the term, that's this number here. How many years are we calculating for? 5 years. So that's 5. Now, how do we solve this question? Well, we could put all the numbers together and solve it all at once, but that could be a little too complicated. So I'm going to break it down into steps. Let's start by calculating this part here. We call this the exponent because this is a number that we've raised to another number. And this number is going to be a decimal number. And it's probably going to be a very long decimal number. So we'll calculate this first, N times T. That's all that is, N times T. Well, N is 4 and T is 5. So 4 times 5 is 20. Okay? So that's our first number. So what we'll do is we'll substitute NT with 20. Now let's figure out this part right here. We need to figure out what this is equal to. So we have R over N plus 1. So R over N is 0.03, that's R, over 4. And over just means divide. So 0.03 divided by 4. All right, so divide 0.03 by 4 and you get 0.0075. So that's what this fraction is equal to. Add 1 to it, because that's what we're doing here. It's in brackets, so we do this first. So add 1 to that number. You get 1.0075, and that's what we put here. All right, already you can see the formula is getting a little bit easier because now we only have 3 parts. So what this is we raise 1.0075 to the power of 20, and then we multiply it by p, which is a principal, which is 5,000. So when I put this in a calculator, I got a really long number. I'm not going to write the whole thing, but here's what you need to remember. Don't do any kind of rounding, even a little bit, until the very end. So although I've rounded it when I wrote it down here, I didn't actually round it down. I found the answer, 1.0075 to the power 20, this really long decimal number. I kept it on my calculator, I saved it, and then I multiplied that number by the principal, which is 5,000. If you round it now, your final answer will not be accurate, or it could not be accurate. You never know, but it's a good chance that it won't be accurate. So do not do any rounding here. Whatever number your calculator says, use that multiplied by 5,000 or whatever your principal is. In this case, it's 5,000. And the answer that you get there, that's your final answer. That's when you do your rounding. So I got an answer, and I rounded it to 2 decimal places because we're doing dollar amounts. And the answer is $5,805.92. So that's the total amount. Now, how much interest did she make? Well, she started with 5,000, and now she has $5,805.92. So just subtract the total amount minus the principal. 5,805.92 minus 5,000. Her interest was $805.92.